Okay. All right. So now we reintroduce the x and y. Can you see that?
Yes.
Remember, normally with the equation of a circle, only x squared plus y squared, and then equals to the other side. It's equals to the r squared. I mean the radius. I get it.
Mm-hmm.
Yeah. But our equation y must be gathered one side. What do I mean? I mean this. Our equation is normally like this. In the parentheses, x, Elizabeth is a, I think you guys, and then also y, let's say minus or plus b all squared, then equals to the r squared. Do you understand? So I'm trying to say that y shouldn't be on its own, but even if you leave it here, it's still correct because there's no longer r, it's only x and y, but I'm gonna take it to Ntwena and Ntwena in this format. Can you see this format, man?
Mm-hmm.
Yeah, because it's actually done there. So if Kingwala in that format, which are kinali Ntwena, kinali x x, what is it? Okay, let me just do this first. Carry x squared, and then carry plus the y squared, and then minus the y. And then I'm going to make a lecker space there, carry equals to 0. Now, remember that format. Remember, there was a time where you need to complete the square. I saw.
Yes.
Yeah. So the first one, yeah, x is fine because yeah, x it's actually 0. It doesn't have the other terms, so it's actually x squared more. Then plus, I need half the coefficient here y. You see, which is minus a half, isn't it? All right. So which means kinali plus y squared minus y, then plus in the parentheses minus half squared. Add it on both sides of an equation. Then even minus 1 all over the 2 all squared. So what's in the green box? It's a perfect square. So now we now have x squared plus, open the parentheses, y minus the half all squared equals to 1/4. So if I even use that x squared to write it to know what is the a and whatever, so that means I actually have x minus, I could use plus, it doesn't matter, all squared, and then plus into y minus a half all squared equals to 1/4. So that means you've got a circle that has its center at 0 half, and then whose radius is the square root of 1/4, which is actually 1/2. So the white one, it should be, is the answer. Even here, any white one, it's okay. Did you get it?
Yes. So is the answer
the white equation? Yeah. So that means this equation, r equal to sine theta, it is actually the equation of a circle centered at 0 half with that radius there. Okay, let me do this. Let me do this for you. All right. So I draw a Cartesian plane. Redraw a Cartesian plane. Now, Ki batla center ya ka ibe 0 le half. Okay. Meaning, let's just make this 1. No. Yeah, maybe I want it to be somewhere in the middle. Yeah, right here. Mona, let it be half. And then right at the top, ibe 1, right there. And then down there, it's 0. So the circle, it's centered here by the yellow dot. Then the radius, ki half. So, which means from half to 1, ki half, the circle will pass by the blue dot. And your co-origin will pass there. So that means the circle comes like that. And you do know when, how about file this r sine theta? Let's go here. Let's write it next to it. When they give me r equals to, I want to just say 1. I want to put it as 1. And then sine of theta. I want to put 1 also there. All right. These are the flower ones, the rose ones. Hi, Kirne?
Yes.
Yeah. So remember, innerly a leaf. Okay, first let's talk about the number of leaves. Okay, number of leaves for this one. It has, remember when the angle is odd, it's 1 theta. That's what it is. It's 1, innerly 1 leaf. Hence, innerly that 1 circle, because it's not going to come maybe it's all those kind of a thing, you know, or it's not going to come and make all these things. You know what I'm saying?
Yes.
Yeah, those kind of a thing. All right, so it's 1 leaf. And then the one okakwa mona, that one, it represents the diameter. It's actually the diameter. So when you divide it, it gives you the radius, yeah, half. Can you see that?
Yes.
Yeah, so even if you're to give yourself special angles, you are gonna come up with this one here. Like, okay, let's take an example. Let's take okay. Remember sine. Sine does not start from 0 degrees like here. Only cos starts kamo. You understand?
Yeah.
Yeah, where sine, the leaf starts, where it starts. Where it starts, it normally starts by, we always say 90 divided by the coefficients of that theta, meaning 1. So which means click on 90 degrees. So it's going 90 degrees. So it's going to start go pi all over the 2. You see that? With that, so you can, so that means it will be starting mona along this. You see those 2 points. Can you see that?
Yes.
All right, let's take 0 degrees. If we put 0 radian, 0 means I'm actually pointing in that direction. More white spot. Okay, let's make it a red dot. I'm standing on a red dot. I can spin around while I'm standing there. Right. So while I'm here, standing there, facing to the right, I don't have to write. I'm just using that arrow as facing. Then when I do sign of 0, key 0 times 1 key 0. So that means as I'm standing on that spot, looking in that direction, how long should I move? I should move 0. So the first dot iba mon. Why what?
Yes.
All right. So let's take 45, because 45 is about somewhere here. All right, which is 1/4 pi. Okay. At 45, sine of 45, I know it's root, it's 0.707, and then Hari Tamisaka 1 is 0.707, almost 1. So that means if you are facing in that direction, so the red indicates where you're facing, and then I'll use orange to measure the length from the dot towards that where I'm looking. 0,0,0,7 something. It will be right there on that dot. Do you understand? Can you see what I'm saying?
Yes.
Yeah. And then let's take 90 for instance, Elling straight. For 90, which is pi over the 2. When you do sine of 90, you actually get 1 times by the coefficient 1. So kiki 1. So go 90, you're pointing, the way you are looking in that direction through the red. But I'm going to use orange to determine the length. Then we know it's 1. So that means from that red dot, I must go upward 1. I must go up to here. So you can see the next dot, Iba Mona. Is it making sense, my friend?
Yes.
Yeah. If I were to take another one, meaning 135,
welcome to my engineering.
It will be here. So that means I get so kiki that one, kiki that circle. So I'm just confirming it from the pole. I'm drawing it from the polar side, and I drew it from the Cartesian rectangular side to show you get the same graph.